Conservation of linear momentum. The linear momentum is conserved. It means P equals to constant. And a quantity is conserved, yani this quantity remains constant, it doesn't change its value. P equals to constant. The derivative of a constant, 0. Ps equal constant, dp by dt equals to 0. And we know that dp by dt is sigma f. Therefore, sigma f equal dp by dt equal to 0. The sum of forces equal to 0, it means the system is isolated. يعني, an isolated system, the linear momentum of an isolated system is conserved. What are the applications of conservation of linear momentums? We have 3 applications: collisions, explosions, and recoil of cannons, rifles. هلا رح نحكي عن كل وحدة بفيديو لحال. The first application is explosions. If the explosion of a solid, which is torn into pieces, lasts for a very short while, external forces are neglected relative to internal forces due to explosion, the solid can be considered as isolated system. يعني على طول explosion يعني the linear momentum is conserved. هذا explosion هي واحدة من applications of conservation of linear momentum. على طول during explosions the linear momentum is conserved, يعني the linear momentum stays constant. Now, a solid S of mass m rests on a horizontal plane as shown in the adjacent document. S is at rest. At rest, يعني it doesn't have velocity. The velocity of S is 0, therefore the linear momentum of S equal to 0. P before explosion. The linear momentum of S before explosion is 0. Now, S explodes into 2 pieces, S1 and S2. S1 travels at V1, S2 travels at V2. Now, my system S1, S2 has linear momentum M1 V1 plus M2 V2. وعلى طول during explosion the system S is isolated, يعني sigma F, Newton's second law, sigma F equal dp by dt 0. The derivative of P is 0, therefore P is constant and the linear momentum is conserved. Therefore, P before explosion equals to P after explosion. Before explosion, the linear momentum of the system is 0 since the system is at rest. After explosion, it explodes into 2 pieces. P1 plus P2, therefore M1 V1 plus M2 V2, therefore M1 V1 equals to minus M2 V2. This minus sign indicates that these 2 pieces will travel in opposite directions. Now, application. Apply your knowledge 6, page 43. An object initially at rest on a horizontal or x-axis explodes into 2 pieces. One piece moves just after explosion along the x-axis OX with the speed 6. What are the direction and the magnitude of the velocity of the second piece whose mass 3 times the first? مثل ما قلت لكم على طول explosion يعني we must apply the principle of conservation of linear momentum. Explosion يعني P before explosion equals to P after explosion. خلينا نسحب نعمل extract للgiven. An object initially at rest. This object is at rest. At rest it has a 0 velocity. 0 velocity يعني 0 linear momentum. Therefore, before collision, the linear momentum of the system is 0, the system is at rest. Now, this object explodes into 2 pieces. So S is divided into 2 pieces, S1 and S2. The linear momentum of this system is equal to the sum of linear momenta of its parts. S explodes into 2 pieces. Therefore, the linear momentum of the system after explosion is equal to P of S1, which is P1, plus P of S2, which is P2. The linear momentum is equal to the product of mass and velocity. S1 has mass M1 and moving with a velocity v1, S2 of mass m2 and moving with a velocity v2. The linear momentum of the system after explosion is m1 v1 plus m2 v2. Now we apply the conservation of linear momentum. During explosion, the system S is isolated. يعني the sum of forces acting on this system is zero. And we know that sigma F equals to dp by dt according to Newton's second law. Therefore, sigma F equals to dp by dt equal to 0. Therefore, P system equals to constant. P, we write P before explosion equals to P after explosion. Therefore, P before explosion, which is 0, and after explosion is m1 v1 plus m2 v2. We solve for v2. We get v2 equals to negative 2i.